So we're going to start with some review of finding the key points when we're going to graph a rational function. We're actually not going to graph today. We're just going to look for the X-intercepts. I'll put that in parentheses because there can be one or many. We're going to look for any holes, any vertical asymptotes. And again, all of these should be, there could be some or none. And the horizontal asymptote. And that's if applicable. Not every rational function is going to have a horizontal asymptote. So we're going to start with the x-intercepts, and hopefully we recall that to find an x-intercept, that's where the numerator is going to equal 0. So in this case, if x were negative 3. If x were negative 3, negative 3 plus 3 would give me 0. And as long as the denominator is not 0, 0 divided by anything is 0. This function is not going to have any holes because it doesn't have any factors that are going to divide to 1. The vertical asymptote is any value of x that causes the denominator to equal 0. In this case, 2. If x were to equal 2, this function would be undefined, since no matter what the numerator is, we'd be trying to divide by 0. And again, since it's not 0 over 0, which would make a hole, it's going to give us a vertical asymptote. The last thing we're going to look for is the horizontal asymptote. The horizontal asymptote comes from looking just at the largest term in the numerator and the denominator. For example, if we were going to zoom all the way out on this function, we wouldn't really have to worry so much about adding 3 or subtracting 2. So then we would just be left with x divided by x, which will equal 1. So we would have a horizontal asymptote of y equals 1. Later, we'll learn how we can put all of this together to create a graph.